Hello everyone, today I will be going over my 60 bits of RAM that I built in Builderment. So this whole section here is my 60 bits of RAM. And to split it up into its two components, I have 3 decoders here, and then 15 sets of 4-bit D flip-flops for a total of 60 bits. So why don't we get started at kind of the input. So with RAM, what you want to be able to do is read and write to it. For my purposes, I want to build a CPU eventually. So in order to do that, it's easier if I can read 2 registers at the same time. So if I want to do any arithmetic on them, I want to be able to read 2 registers and add them together. So in this case, I have 2 decoders, one for the first read, one for the second read. And then I also have another decoder to select the address I want to write to. So if I want to change any value in my RAM, I have to set the address of the RAM I want to change and set its value. And then over here, this is where I set what value I want to change it to. So this is what I want to write to. So if I want to change register 1 to a specific value, I would set register 1's address here, and then I would set the value in here. And then, based on those read decoders here, those get fed through my RAM here and get outputted here. So just to show off what I have done, each of these strips is 4 bits of RAM, and there's some specific features I added in order to read them with 2 registers and write to them as well. But let's just show off what each of these are reading. So for each of these sections of 4, I included a mini display as well, mainly so I wouldn't go crazy if I needed to debug something. So these currently show what is in the register. So in register 1, I have 0001 stored within that. For my own purposes when testing, I made sure that the address matched the value inside. That was just so I made sure I was writing to the correct ones and everything was working. So register 1 has 1 in it, 2 has 2, 3 has 3, 4 has 4, etc. all the way down to 15. So why don't we get into it? Why don't I show it off a little? So why don't we start with reading? So why don't we choose to read? Let's go with register 4 here. And then over here, let's read register 15. Now you may be wondering, why don't I have 16 4-bit cells? And that is for a specific purpose where I have created some OR gates, but they are not very good. And when I say that, they only work if one of the outputs is on or if all of the outputs are off. So if 2 of the outputs are on, it breaks. So one of the requirements of using this RAM is whenever you're changing anything, you need to set it to 0 first, leave it for a bit, and then set your new value. And that's for the reads and the writes. Mainly because signal propagation in Builderment is not instant. So if I were to turn on register 15 on my decoder and then turn it to register 1, 15 would stay on and 1 would stay on as well. And that would cause problems where if both bits were 1, it would destroy an OR gate over here. And not destroy, but it would cause these belts to no longer be full, which would slow down the system when you change to 0 because it would have to backfill. This whole system works on making sure all the belts are full. Let's just check in here if we are reading any values, and we are. So like I said earlier, every register has its value as its address right now. So we wanted to read register 8 and 15, and we are reading 8 and 15 as our outputs. So that's working perfectly. Now, why don't we do a change of one of the values. So let's go to register 15 and let's change its value to something. So to do that, I have to turn all these signals on. So now we are sending our address as 1111. And let's see what we should change that value to. We could change it to 000, but why don't we set it to 0101. So that would be a value of 6. And while that's running, I can show off kind of how these decoders work. So the decoders work by having 8 signals in total. So I have my 1 bits here, and I have some 0 bits as well, some inverted signals. Sorry, these are my 1 bits, and then these are my 0 bits, my inverted bits. And then each of these decoders, which is just a 4 input NAND gate, check to see if all the same values are present. So if it matches whatever I code into each of these, it should work. So this corresponds to 1, 2, 3, 4, etc. So if we go down to 15, we will see that this gate is flowing. So currently 15 is being written to, while you can see 14 is not. So let's scroll on down. So it's still waiting a bit on the display here. Remember, we set it to, I believe, 0101. So it takes a long time for this to propagate, but it will get there eventually. Oh, and here we go. It's about done. So 0101. And this display is slower than the actual circuitry as well. So this is kind of last in line to update, mainly so it doesn't slow anything else down when I implement it into a computer. And as we can see, this display is also updating. So this would be the main update. The main output of the circuit. And as we can see, we are outputting the correct value. Let's see. So it's very hard to see how this actually works. I'll eventually make a tutorial on how these NAND gates work, a better one. But it's all based on flow. But let's actually see the circuit diagrams I worked with here. So this is a nice website I found that does simulations. So this would be I'm just focusing on one DRAM cell right now. So this is 4 bits. So if we want to set a value, we can set it to 0000. And then if we change the write enable, it sets it to 0000. If we change it to 1110 and we have write enable true, then it changes to 1110. And then if we set any of these read values, it outputs on the main output. And both of these can be on at the same time, and it works just fine. And then as for the system on the whole, I have my decoders here. So I would input 4 bits here and then turn on one of those D flip-flops. So going back to here, this write enable will only be true if the current decoder is set to the correct value. And same for these reads. The write values get propagated to all my D flip-flops all at once, but it doesn't affect anything. For example, if I change these values, it won't change any of my outputs if the write enable is false. So that's how my system works from a larger perspective. And I think that about wraps it up. Yeah. I hope you enjoyed, and I know this has been took a while to make a video on this. I've had this done for about a week now, but yeah, got a little burnt out there for a bit, but hopefully I'll be able to continue making updates and eventually get a full CPU working. Thanks, hope you enjoyed.